So Don, next slide, please. So as far as the agenda today, we're going to be starting with showing you how to set up the machine tool coordinate systems, use of setups to define work coordinate systems, and then we're going to be showing you the flip machining, which also a little bit of 4+1 machining after that, and then fixture offset programming, XY instancing, and there might be a little bit of a change here in the agenda. So we're actually going to be showing you all the 3-axis indexing first before going to the 4+1 machining, and then the 4th-axis rotary instancing, and then finally the 3+2 machining. And we'll also talk about post-processor considerations at the end. My name is Joe Anand, and I'm the product manager here, and I'll be joined today by Don LaCourse, who's going to be talking about, I was actually showing the doing the demo and the webinar actually. And also we want to keep this as interactive as possible, this webinar. So if you have any questions, I will be in the background looking for questions, and we'll do our best to answer. Just put them in the chat window on your screen, on the GoToWebinar screen, and then we'll be able to answer that, either stop what Don's doing or just answer it in the chat window itself. So, all right, Don, go ahead.
Okay. Hello, everyone. Thanks for joining us today. Hope everyone can hear us okay. And we got a real jam-packed, interesting webinar to go through today. And if you're interested in index machining, you're going to really like this one. So what we're going to talk about the coordinate systems in flip machining. As Joe mentioned a little bit there at the beginning, indexed machining means that your axes are locked in one particular orientation, whether it's in 3-axis, it's locked by default. 4-axis, you're locking one of the rotary axes, you're locking the rotary axis in a certain orientation. And then 5-axis, where you're locking the axes in multiple orientations, the 4th and the 5th axis, so you're locking those. Now, when all of these are locked, we're performing 2 or 3-axis operations in that locked orientation. Okay, so let's go ahead. If you look here on the left here, these are your standard 3-axis coordinate system, Z being up at the spindle. And then if you look in the middle here on 4-axis, you have your typical 3-axis operations as you did on the left, but you also have a 4th axis that is rotating. And in the 4th axis, this rotating axis is locked in place at any particular angle, 20 degrees, 30 degrees, whatever. And then over here on the right, you'll see your 3-axis orientations here. You have those as you do in the 3 and the 4, but you also have 2 additional axes for the 5-axis machine, axis 4 and 5. Those are locked in place at any particular orientation that you're machining, and then you're machining the 2 or 3-axis operations in that locked orientation. Now we're going to start out by talking about, we're going to work our way up from 3-axis to 5-axis. So what you see on the screen here is a 3-axis, 2-sided part. In 3-axis, you have an index by default. In other words, when you start machining, that's an index position by default. So even though you can't move it around or anything, it's still fixed by default. So if you have a 2-sided part, you're taking that in-process stock and you're flipping it over, and that becomes another index position. So if in the realm of indexing, the 3-axis also has indexing built in, even if you're not really thinking about it. So in this particular part, we're going to show you all these parts, by the way, after the presentation. But in this particular part, We have a multi-sided. We have the top that we're machining and the bottom that we're machining. In this particular example right here, we're showing you the professional configuration, which allows you to machine both sides, top and the bottom, in the same file, same machining job. So you can set up a second setup for the bottom, and each of these setups in 3-axis, you can consider them as an index position. And versus if you're running the standard or the express configuration, or even the expert configuration, you can only have one setup for milling, okay? So when you bump up to Pro, that's when you can get the multiple setups and all of the advanced operations to go with that. And Joe, if I'm forgetting something, feel free to jump in and clarify.
Okay, no problem.
Okay, let's go. Now we're going to stay with the 3-axis, and what we're considering, we're adding indexing and end with this webinar. So we show here polar instancing. You can do XY instancing or polar instancing, and we're going to show you both of those. But in this example right here, we have programmed one of these instances here. You see down here in the part itself. So all of these operations here shown in the machining job are for one instance. The operations that are above it apply to the entire part. So those aren't being instancing. So I have a roughing and some profiling, etc. to machine the inner, features and stuff, and then the outer perimeter. But everything that defines one set of features is programmed, and then we define a polar XY instance. This is this folder right here. We just drag and drop the operations in there, and it becomes a polar instancing setup. So let's go ahead, and this is a second view of all of the instances being displayed. If you select, after you move all the operations in the Polar XY instance folder, just select the folder and all of the instance toolpaths will be displayed. And when you post, those will all be posted out as instance 1, instance 2, etc. Any questions? Go ahead and put them in the questions panel. Okay, now we're going to move to fixture offset programming. A little bit unlike the XY instancing, is in fixture offset programming, you actually define a fixture, which is a G54, G55, etc. Those are the typical codes for your fixture offsets. And you do that by defining a work 0. So what we're doing here is we're defining a work 0 for each one of these parts. And then we're assigning that work 0 as a fixture offset number. And that G54, etc., will be posted out, allowing your machine to understand that you're machining a second instance setup. So in this particular file, we got 4 instances. We got 4 work 0s. Each one of the work 0s are defined as an offset. And these G54s, they can be whatever code your machine uses for fixture offset programming, and you can define them in the work 0 dialog. We'll show you that. Let's go to the next slide. Just one second. So we're just working through here the different fixture offsets. Okay. Now, in 4-axis, we call it 3+1 because you have your 3-axis operations, okay? And then you have, and excuse me, my throat is a little sore. And then you have an additional 4th axis, which you're locking in place while you're performing these 2- and 3-axis operations. So here in the picture, you see that the fixture, the instance that you're machining, you're indexing it at a particular angle. In this particular case, you're indexing it at rotation angle of 0 to do the top side, and then you rotate the setup 180 degrees, so the rotational axis is rotating 180 degrees, and then it's locked in place, and then you machine the bottom side. In this particular example, you could do this also in 3-axis flip machining, but we're showing you how you can also do it in 4-axis. Okay, continuing with 4-axis. In 4-axis, you can also do what's called radial index machining. Similar to the instancing, we program one set of features here. You'll see that under the rotary instance program folder, we have facing, profiling, chamfering, drilling, etc. That's all to define one instance of these features right here. Then we define the rotary instance, and that's where you define how many instances you have, the rotation angles between them, etc. And then you just drag and drop the operations from the top into the folder, and then select the folder, and you'll see that all of them will display. And then when you post that, again, it'll be posted out each instance all the way around 360 degrees. Now, for the really interesting part, we're also going to talk about indexed machining in 5-axis. Okay, so if you look at this little picture here down in the bottom left, you have your 3-axis, 3 axes and 3-axis machining. This is for your typical 2 and 3-axis operations. And then you have your 4th and your 5th axis, which are oriented to a certain position defined by the setup, and it's locked in place. So you're performing the 2 and 3-axis operations in an orientation that is locked. So if you look at the machining job, we have 3 setups, okay? And in the picture here on the right, we have a part that needs to be machined from multiple sides. So instead of taking the part off or the stock and process stock off of the machine and turning it over like you do in 3-axis to do another side, you can program these all in one file, and you can define each of the areas that you need to machine as an individual setup along with the work 0. So with the 3 orientations that we're machining for this part is the right side, and you look at this, the blue arrow is the direction of the Z-axis. So we're machining the right side, the left side, and then the top side. And this is labeled 3+2 because you have your 3-axis, and then you have 2 additional axes that are locked in place. And looking at the machining job here, you just defined your setup 1 is defined by default. That is your Z top. And we're adding 2 additional orientations for both the right and the left side. And here we're looking at each of the orientations and what the machining jobs that you need for this particular orientation. So I mentioned the setup 1 is the top by default with your Z pointing upward, and we're performing facing, we're doing some roughing, profiling, some boring, etc., to machine all of the features that we can get to from this top side orientation. And one thing I want to mention in this, you see this little picture right here with the face mill. That's to machine these fins, the slots that go through these fins. And you can do that either with a profiling or with a T-slotting operation. We just did it with the profiling. And here we're just showing each of these side views. We got a right side view that's set up 2, oriented for the right side, and then set up 3, oriented for the left side. So just to reiterate here, the axes on the 5-axis machine are being oriented for the right or the left view, and then they are locked in place. They do not move. These 4th and 5th axis do not move, and then you're performing 2 and 3 axis operations in that indexed orientation. And here we're talking about post-processing. We'll show you how to post-process and multi-axis indexed machining, and we'll take a look at the G-code as well. Any questions? Go ahead and put them in the questions panel. If you think I'm going too fast, go ahead and tell us.